This video is going to be on the ALEKS topic, closure properties of integers and polynomials. So let's first define these two words. What is an integer? You may recall an integer is a whole number, not a fraction. They can be negative, like -2. This includes 0, and it could be positive, like the number 7. Polynomials, however, are a little bit different. Polynomials are what you might think of as expressions, but it's not just all expressions. Let's take a closer look at what a polynomial is. A polynomial can be expressed in terms only that have integer exponents that are positive integer exponents, and the operations of addition, subtraction, and multiplication. Okay? So in other words, it must be possible to write the expression without division. So if it has division, then it's not a polynomial. It's easiest to understand what makes it a polynomial by looking at these examples. So let's see. Do you see how this expression has a positive exponent and you're just adding these terms together? This is a polynomial. Here, this is a polynomial because the x is also a positive exponent. You can't see it, but this is x to the power of 1 since there's just one x. This is a polynomial because all of these exponents are positive exponents. Remember, when we have a negative exponent, that's like doing the inverse, 1 divided by this, and that would make it a fraction. So even though multiplication is happening here, this is still a polynomial. Now this is not a polynomial because it has a -2 in the exponent. This is not a polynomial, again, because it has 1/2 a fraction in the exponent. This is not a polynomial because this is going to be dividing, right? And when we have 5x plus 1 divided by 3x, that is no longer a polynomial. And this actually is a polynomial because if you simplify this, this goes, when you divide 6x squared by 3x, you get positive 2x. And when you divide 3x by 3x, you get positive 1. So this actually will simplify, and this should say 2x plus 1. Actually, I should inform this person on the site. All right, so let's go ahead and see if these are always, sometimes, or never true. An integer added to an integer is an integer. So what we say is this is closed under addition, right? Because no matter what two integers you add together, you're going to get another integer, like -2 and 7. You put them together, you get 5. That's still an integer. So this would be always. Let's go ahead and write that. This would be always. We'll say A for always, S for sometimes, and N for never. An integer subtracted from an integer is an integer. Well, let's see. If we did 0 minus 7 and we got -7, is that still an integer? Yes, it is. And can you think of any examples where we wouldn't have an integer? No, that is because it's always going to be true. That means it's closed under subtraction. So it's closed under addition. It's closed under subtraction. What about if we divide? What if we did 7 divided by -2? Is -7 divided by 2? That would give us -3.5, right? Because this has a decimal, it's not a whole number, this is not an integer. But could you think of an example where it would be if you divide it? Sure, what if we divided 0 divided by -2? That's equal to 0 still, right? So sometimes it is, and sometimes it's not. It's not closed under division. Sometimes an integer divided by an integer will still be an integer. Now, what you have to remember about polynomials is it has the same properties as integers. So they are closed under subtraction. No matter what you subtract, it's still going to be a polynomial. No matter what you add, it's closed under addition. Any polynomial added to another one will still be a polynomial. And they also are closed under multiplication, because you remember that example we had before, when we're multiplying these polynomials right here, we're still getting a polynomial, right? We can actually do this problem. 3 times x would be 3x to the 8th power plus 6x to the 5th power minus 15x, and that's still a polynomial. So they are closed under multiplication, just not division. So a polynomial multiplied by a polynomial is a polynomial? Yes, always. That means this is closed underneath multiplication.